Hi class, welcome to this section on logistic regression models. We're going to explain a little bit. This is a classification model where we are trying to predict what category a customer might fall into. Just a small reminder, we have a review of simple linear regression. Usually this is for continuous data, things like age, any type of integer where you can have, a decimal point and just continuously have more and more variables. And there's usually a direct correlation between one variable, an independent variable, and its impact on a dependent variable. We also have the line equation. As you can see, y equals BO plus B1 of X. And this is also represented in the sample regression line. As you can see, y hat. BO is the constant, B1 is the regression coefficient. And we use the multiple linear regression models when we have, when we have two or more independent variables having some sort of impact on dependent variable. You can see here the comparison. When we look at it on a line graph, we see that linear regression, if we try to draw a straight line through this type of categorical data, it wouldn't really make much sense. Therefore, we need some sort of S-curve that can capture all of the relevant points. So, simple linear regression, we have one impacting variable, and then we have multiple. We also use OLS, which is ordinary least squares, with the linear regression, while we use MLE, or the maximum likelihood estimation, with the S-curve. You can see here a little bit better. It's a sigmoid function, and it gives you that S-curve. Y will become, if the curve goes positive, you'll see that Y will become a 1, and if it goes negative, it'll become a 0. So usually around 0.5, about 50%, that's the threshold at which we'll classify it as either a 0 or no. If it's below that threshold, or if it's above it, it's automatically a yes. So some of the types of logistic regression, you have binary logistic, you have multi-nominal, and you have ordinal. I mean, you can read the definitions right here. Once again, binary is a target variable, only has two possible outcomes. Multi-nominal, you have three or more nominal, and ordinal, obviously they're all in order to some sort. So for our business case, we've got a company wants to investigate social media advertising. For this assignment, please download the social network ads CSV. Watch the video first and then rewatch it, follow along with the code. Let me know if you find anything I did wrong. I'm really capable of doing a lot of that. So Acme Media wants to know who it should target with its ads. You've been hired as a data scientist to analyze who will most likely buy a luxury SUV. It wants to categorize the customers into a yes or a no and predict who's going to buy or who's not. Our data set contains about 400 records. There are 4 independent variables: user ID, gender, age. We'll see the code again. Things going a little bit fast for me. Logistic regression code, part 1. So as you can see, I am opening RStudio. I'm going to go to where my CSV file is stored. I'm going to open that folder. I'm going to set it as a working directory, and then we'll begin to code from here. And I will let you kind of type along with me if you need to. I'm not going to do a lot of explaining at this part of the video. I will jump back in. You already know this stuff. Let's see. Yeah, we're just going through it, and we're adding the CSV in. We're reading it into, and we're taking a look at that. We see gender, age, estimated salary, and purchased. And what we're going to do is we're going to disregard some of the columns because we don't need that information. It's basically irrelevant. So we're just going to reduce the data frame to the columns that we actually need. And that's going to be your columns 3 through 5. Okay, because looking at it, 1, 2, 3, 4, 5. We need age, estimated salary, and purchase. Okay. So that's what we're going to take for our model, our algorithm. We're going to try to create our training set and our test sets based off of just those to see the relationship. So highlighting and pressing enter, we've now reduced our data frame to just these 3 variables. And purchase, as we know, is the dependent variable. And we've got age and estimated salary as what we're seeing the impact and how much we can do so. So next step is we're going to split the data set. And you probably have this already as far as code from previous exercises. If you do, feel free to just copy and paste. That's the efficient way to do it. I'm actually working on a different workstation, so I'm actually going to just type this. I apologize if I type slow for some people in the back. That's how I work. I'm thinking as I'm typing, so usually I'm kind of screwing up a little bit. But I'm going to go ahead and I'm sure you guys already have CA tools already installed and all that. If not, you will look here, packages, see that that's installed. If it is installed, it will already say that. And to activate it, you just need to use the library command. And I can speed this up, but I typically, when I watch tutorials and videos, when I speed this stuff up, I end up just rewinding it like you wouldn't believe. That set seed command is so that we all get the same results. And here, we're going to split our sample up. So we're going to create the training set, and then we're going to create the test set. And here, we're making it so that the split is on a dependent variable for purchased. That's what we want to set it to. And this time, because we've got 400 observations, we're going to set it at 75% instead of our usual 80%. And that's so that we end up with about 100 records in our test set. So you'll be able to see some observations. It's a pretty large data set. You always want to take a look at your data set and just look things over before proceeding, because you want to check for missing variables, things of that nature. That's part of the data pre-processing phase. But with this, as I said before, we already had this as a template, but I'm recoding this just so I can kind of make sure that everything goes well. Not to mention I'm working on a different desktop. So with the test set, we're going to take a subset of the data. And you can see that we haven't executed it yet, so don't freak out if you don't see me executing yet, because I'm just trying to kind of get through the typing part. But yeah, we've got our subset created. Now we actually need to conduct feature scaling, and the reason for that is because in our data set we have 2 different scales of variables, age and estimated salary. If we try to graph these both, you will see 18 as a value, and you see 35,000 or whatever the value is, and that's really hard to see. So that's the reason why we're selecting exactly what we want to put as scaled values, so that we can make them even, so that they can be represented visually and it makes sense to the end user. And I'm also going to do the same thing for the test set. So we just need to make sure that those values are comparable and that they visually are represented. Now we're going to fit the logistic regression model to the training set. So the way we would go about doing that sorry, is we would use a classifier. And this is basically using the GLM function, and you can look up the GLM function in the help file, and you can see that we need to present it with arguments. The arguments are going to tell us exactly what's required in this function for GLM. So if you look and you see the arguments, you'll see formula, you'll see family, and you'll see data. Those are the three that we're going to focus on. So in this event, we're going to set formula equal to purchase, which is our dependent variable. We're going to use the sign to select the rest of the data set as far as the columns or the variables. Then for the family function, which is our second argument, we are going to set this to being able to classify our customers in one out of two categories. So we want to use a binomial. And that's basically just stating that we want to make sure that the customers are predicted to go into one category or another. Finally, you want to set our data to the training set, because that's what we're going to train first, and that's what we're going to work on. Okay, hopefully that makes sense. Next, we're going to do exactly the same thing, but this time we're going to predict the test set results. Okay, and this should be fairly logical to you. If you have any questions on this, please reach out, let me know. But let's do the same exact thing. So now we have our test set. We've got the 100 variables, our 100 observations out of the 400. Our training set contains the other 300. And of course, that's all with 3 variables, right? So it looks pretty good. And let's see what we're getting here. In our test set, we can see we've got age, estimated salary, and purchase. Okay. So going back, now we see it. We have to predict the test set results. So what we're going to do is take a look at our data set and see some of the values. We see in a purchase column, we have zeros and ones, and the 0 represents not buying or no, and the 1 represents a yes. So we have set this. I know I made a little error there. We've set this, and now we're seeing that we have scaled the values in age and estimated salary. So now you can see the values there can actually be graphically represented, and they look like they're on the same scale. So now I'm going to create the classifier. I'm going to go ahead and execute this. And now we can see the classifier. We open it, we see the values and everything, and I'll let you read through those values as you execute your code. It's telling us a great deal of coefficients, it's telling us effects, it's telling us relationships and things of that nature, but just for brevity's sake, I'm going to let you read through that on your own. So in order to predict the test set results, what we're going to do is going to create an pred, and this is going to be using the predict function. And in here, we're going to use that classifier that we just created in a previous section. we want to set the type, and this is going to be a response. Now, we also want to work on new data, because now we want to operate off new data from the test set. So this is where we make the prediction. And we're going to select to use the age and estimated salary, but we're not using the purchase column. So that's why we've used the -3, and that's just to make so that the prop pred contains both of those values, but it's not operating off of the dependent variable. So when we execute, we can see now we have our values. Now run prop pred down in the console. We can see that 2 has a pretty low probability. It's predicting has a pretty low probability of the customer buying. So we can set this equal to make it make better sense by making sure that the decimal number here, the extended integer that we see, is just represented by a 0 or 1. So the way to do that is with the if-else statement. Sorry. And what we're basically saying is, if it's at a threshold of greater than 0.5, it's a 1, which is a yes. And if it's below a 0.5 or 50%, then it should be represented by a probability of 0. So now, if I look at this observation, let's say the first one, I'm going to look at observation number 2, and it has a 0, which means the customer did not buy. So if I were to go up, and let's see here, I have some 1s here. If you look, you'll see 0s and 1s instead of those long extended decimal numbers here. So let's go up and look. You can see here 2, age, observation 2, you see that it's 0. Let's look at some other ones just to kind of make sure that we're on the right path. Let's see. We've got a 1 here, and that's observation 22, and we see a 1. So this is fairly accurate. You can look at observation 104. Let's see, we have 104. Yep, and we see that that's a 1 as well. So we kind of get the idea that we made our prediction. It seems to be fairly accurate, but we have to figure out how accurate it is. So obviously any estimation or prediction software is not going to be 100% every time you run it. Sometimes you will get 100%, and other times it will be very close. It'll be 90-80%. So we need to check this out. So to do this, we're going to create something called a confusion matrix. What the confusion matrix will help us understand is exactly how many predictions our prediction model got right compared to the test results, and how many it got wrong, so we can kind of calculate a percentage. I'm not going to do the percentage calculation in this video, but we will be able to look and see exactly what the confusion matrix tells us we got right or what we got wrong here. Okay, so I created confusion matrix. That CM stands for the confusion matrix, and it is comprised of the test set, takes out the it looks at the dependent variable in this case, and then we've got ypred, which is the prediction. Okay, now I'm going to execute. One sec. So I'm going to execute. And now, if we were to, so we know everything seems to have worked without an error, but if we were to go here now, and type in. Let's try it in the console here. There we go. So our confusion matrix has yielded that YPRED has, and you can see, and I'll tell you how to read this, in a column in a row you see 57, and they're both under the matching values. And then in the other one, in the other column, you have under the ones, where the ones meet up, you see 26. That's telling you what you got right and what you got wrong. So we can see that we have 57 correct values, and we can see that we have 26 correct values. Where you see, whoops, sorry about that. Yeah, all right, so you can see that you got those values correct. All right, and if you were to go and look at the, when we go do the visualization, you'll see that it represents the outliers, okay? So for now, go to RStudio, go to the website, and download the LMStat Learn package that I mentioned earlier. I'm just gonna copy and paste that code here because this is just basically it's visualizing it. So I have provided that code section for you. But the LMStat Learn package is an archive package that's no longer supported with RStudio. Okay, so what we need to do is we have to install it from the website, and then when you bring it over, you'll go to tools, and then you'll go to packages or install packages, and then you'll just look for wherever you download it. And I provided the links for that as well. But now I'm going to execute. Haven't explained this code yet, but you can see it running with the stop sign. That means that RStudio is processing, and I'll explain what this is doing. But what we're trying to do is predict a linear function, because we have two independent variables acting on the dependent variable. So for the two, we know that it's going to be a binomial, so it's going to be a straight line. So let's see what happens when this thing finally executes. Apologies, my computer is pretty slow, even though it's supposed to be fast. I guess I need to add more RAM. All right, so we see our logistic regression training set, and that's what I executed. It's just on a training set. So we see here is we see red values, red coordinates inside of a red zone. You do see green values or green dots inside of the red zone as well. And this is what I was talking about with the confusion matrix. You see red dots inside of the green zone. So I'm also going to do the same thing, but this time we're going to do it for the test set. Okay. So what those red dots represent is the actual values that we've observed. The red region is the predictive region. So that's what we've predicted as our threshold. And again, that straight line is where that line kind of is the cutoff. Should say it like that, the threshold, right? So if we wanted to capture all of the values, the outliers, so the green dots that are in the red region, those represent people who are younger but bought the SUV. In the green region, the green dots is basically telling us that the people who are older with the higher salaries are the ones who purchased the SUV, whereas the red section with the younger buyers, even the ones who made the higher salaries, did not buy the SUV. Okay, so sorry, I'm talking over myself as I code here a little bit, but I'm basically just creating the test set. So what I did was I just went in and copied and pasted and changed where it says training set, I just changed it to test, and then where it says let's see, we had set equals training set before, now we have set equals test set. So that's what I changed. But anyway, looking at the video or looking at the plot, we see that basically the outliers are people who were younger, who earned a high salary or earned whatever salary and yet bought the SUV. So those are the outliers, and that's what's predicted with the confusion matrix. The green dots that are in the red region, okay, wasn't able to accurately capture those. So now when we look at the test set, we can see how well the actual values have been plotted and how well they've been predicted. So now we see we've got mostly red in the red region and mostly green in the green region, but there's still some outliers. If you look at the amount of outliers and you counted them up, the colored dots that are in the wrong region, what you're actually going to find is that it correlates perfectly to the confusion matrix. So all of this seems pretty intimidated. I know I copied and pasted about 15 lines of code there, but they're pretty easy to understand. It's not too hard to get through. If you were to look, if I were to explain to you the code that I copy and pasted, if you look at the code that's here, we're basically saying that the set is the set that we wanted. So set equals the training set, and that the X1 and X2 values are the upper and lower bounds. Okay, we set up a grid, and then for the column names, we call them age and estimated salary, and then we wanted to predict the values. For the Y grid, we set it so that if the threshold is 0 or 50% or 0.5, if it is a yes or predict a yes, it's going to be a 1, and if it's not, then it's going to be a 0 or 0. And that's just how we kind of came to all of this. The rest of it is pretty much you're looking at the visualization or the plot. And I'm showing you here that if you had that CM or the confusion matrix, then basically those numbers coincide with the outliers. But yeah, and then you've got your X label, your Y label, the contours. You're also looking at as numeric, and you're looking at the length and the length of the two variables minus the dependent variable. Okay, so hopefully this was a good exercise for you. Hopefully it wasn't too torturous to listen to my voice for this long. This is the longest video I've posted. It's about a half hour or so. If you have any questions at all, please reach out. I'm going to post the code for this section. I'm posting a code for it, and I'm also going to post that link to where you can go and download the Elim Stat Learn package. Okay. All right. I hope that this exercise finds you well and able to make some progress with understanding it. Don't feel crazy if you don't understand every aspect of the code yet. The intuition just needs to make sense to you. Okay. So the intuition was seeking to classify something in a predictive sense, and that's pretty much it. We're going to use two variables, and that's what we're going to stick with for now. Have a good day.